Welcome back. You've learned how FactFinder can apply a systematic approach to problem solving, and you've learned how to focus in on FactFinder on the right systems at the right time frame for solving this problem. Let's apply the methodology and figure out the root cause. First, start with the user and their complaints at the first servers where the user interacted with the application system. Second, track the transaction across tiers to find the bottleneck component. Third, drill down to find the affected application processes and look at the resources of the underlying server. Fourth, look around for other behavioral interactions that could be causing the problem. And fifth, after you identify the root cause, use FactFinder to verify that the fix you put in place actually restored service levels. The first step, beginning with the user, means starting our analysis at the first service that the transaction interacted with, marked by these orange entry point icons. Now, once you start there, the goal is to follow the transaction hop by hop, starting with the web tier all the way to the back CSCS system, trying to find the bottleneck. You find bottlenecks by finding which server is the source of slow performance, but can't blame the slow performance on machines that it depends on further downstream. I'm just going to adjust the view so that you can see more information about the components on each machine. Let's start with the first web server. To investigate whether it's the bottleneck, I'm going to double click to go into full details mode. Before we analyze whether this Apache server is a bottleneck, I need to explain two important distinctions. The first is the difference between front-end versus back-end measurements in FactFinder, and the second is average response time versus total response time. Front-end measurements show a metric from the perspective of how requests were made to the current machine that you're looking at. For example, front-end average response time measures the response time of this server to its clients. Back-end is the inverse. Back-end average response time, for example, measures the response time of the servers this machine depends on. Average response time is a measure of how long each transaction request takes. Sometimes, a front-end request causes multiple back-end requests. In that case, the individual back-end transactions may have a low average response time, but there are so many of them that it takes a long time for this server to finish the front-end request. Total response time is therefore a roll-up of the average of each of these requests times the number of requests that were made. Alright, now we can see if this Apache server is our bottleneck. In this case, it looks like on average, the response times of the web server have gotten very bad, but it doesn't seem to be able to blame it on back-end average response time. That seems to indicate this web server is a bottleneck, but I'm going to go one step further to evaluate it. Let's look at the actual application process serving the transactions here, this Apache web server. Again, average response time looks bad. It looks like this machine is a bottleneck. But let's look at total response time. From this view, you can actually see that the backends seem to account for most of our performance problem, and that backend response time spikes at the exact same time that our transactions slow down. It looks like this Apache server is just passing on bad performance that he's getting downstream. By following this transaction back and performing the same bottleneck analysis, we'll find our bottleneck. Let's go to the application server. For a shortcut, you can click on the small performance graph, either in the process or on the machine. That'll bring up a pop-up showing the average response time, load, CPU, and memory. If I look at average response time, wow, yep, it looks like his response time has gotten very bad to his clients. But he can't blame that performance on back-end response time. Just to confirm that, I'm going to look at load and make sure that we don't have a total response time problem. It looks like we won't have a total response time problem because the load from front ends and back ends is about the same. It appears that this machine is our bottleneck. Just to confirm that, I'm going to look at a trace of the transaction. Again, a trace is just one instance of this login for one user. Looking at more granular information, like a trace, often makes things even more clear in a complex environment like this one. Let's find a bad transaction trace. I just sorted by response time so I can see the worst transaction traces. Let's try this one at the top. Looking at the trace, it's pretty easy to see the problem thanks to automatic bottleneck detection. Just like our manual analysis, automatic bottleneck detection is showing that that web tier process is the bottleneck for this transaction trace. Also, if you look at the timeline breakdown in the table, you can see that this SOAP request to that application server accounted for most of the response time of this application. That completes step 2 of the methodology, tracing the transaction across the components to find the bottleneck. In the final video in our problem-solving series, we'll drill down into our bottleneck server to identify the root cause.